Here we will discuss the uses of coordinate geometry in various life experiences. Now here you can see that there is a smiley, and how can it be copied? So in order to copy this face, we have to use coordinate geometry. It can produce the exact image of the original image provided to it. So first we provide an original image and then we put copy paste. When we do copy paste, we need coordinate geometry for that. So all photocopying machines, scanners, they use this technique. And even if you are changing the colors, then that also changes the points on the coordinate plane. The colors which we are changing are due to the changes of the points on the coordinate plane. Here we want to find the distance between television and watch, which is the distance P to N. And this distance can be measured using distance formula. First, let us find the coordinates of P. These are the coordinates of the watch. How are they produced? Now look here. Uh, this O is the corner and the television is at horizontal distance, which is x-axis. So the horizontal distance of the television from the corner is O, that is origin, and its horizontal distance is 10 meters. It is given. So what is 10 meters? B is equal to 10 meters. This is horizontal distance of television from the corner. This and this lines are parallel. So both mean the same thing. Now this is A is the width. A determines the width of the room, and that is equal to, it is given over here, it is 5 meters. So A is equal to 5 meters. And the distance of watch from the ground. This line, horizontal distance line is ground, and from there up to P is C. It is mentioned by coordinate C, and that distance is also, it is given 5 meters. The vertical distance of the watch from the ground is 5 meters. So the coordinates of P are ready, which are the coordinates of watch, and that distance and the distance between N and P. N is the place of television and P is the place of watch. These two distances, the distance between point P and N, can be measured using distance formula. Here A determines the x coordinate, B the y coordinate, and C the z coordinate. As per our sum, A is the width, B is the distance of television from the corner, and C is the distance of watch from the ground. See here the most famous, very popular GPS system, which is called the Global Positioning System. The full form of GPS is Global Positioning System. So you can even get the knowledge of its full form. This is its abbreviation. Is a space-based satellite navigation system that provides location and time information in all weather conditions. So this GPS is the long based. What is its use? It is used in to provide locations and time informations in weather condition. What kind of weather will prevail, where and in which time. Even on my mobile, you are seeing that they are providing the weather of the day, and this is all based on GPS system, which is a space-based satellite navigation. But how does it work? It works on coordinate geometry. In a GPS, the longitudes and the latitudes of a place and are its coordinates. So the latitudes and longitudes, they are the coordinates. You can say the latitude is x-axis horizontal and longitudes is y-axis vertical. So you can apply distance formula to find the distance between two places in a GPS. Even if we are using GPS to find the distance between two places, this usually we are using it when we are hiring a cab. You can see that they are showing this kind of map, and this map is all using GPS system, which is also based on the distance formula. Now let us recall the Pythagoras theorem which we have already studied earlier. Right from 7th standard we are studying about it. So let us mention the formula. This, as you know, that C is the hypotenuse. What is hypotenuse? The side opposite to the right angle. So C is the hypotenuse. B and A are the legs of right angle. Now how does the Pythagorean theorem work? A squared plus B squared is equal to hypotenuse squared. It means the sum of the squares of the sides are equal to the square of the hypotenuse. The sum of the squares of the sides is equal to the square of the hypotenuse. So this formula we are going to use to find the distance formula. That's why we should recapitulate first. So after understanding this, we are going to use it in distance formula. Now let us derive the distance formula. We want to find the distance between P and Q. Let us take the coordinate of point P, x1 and y1, and the coordinates of point Q, x2 and y2. Now in order to find the distance between these 2 points, we have to do certain constructions. Draw PR, here PR, and QS, this is QS, perpendicular to the x-axis. Then one more perpendicular is drawn, this perpendicular PT. How is it drawn? It is drawn from point P to a point T, which is on QS. The perpendicular PT is from point P to point T, and the point T is on QS. Now, let us find the distance of OS. What is OS? OS is x2. The distance from O to S is x2. This is the coordinate of Q, point Q. So Q and S, they both lie on the same line. So whatever will be the coordinate of x coordinate of Q will also be the x coordinate of S. So OS parallel to this line, the line from Q. So both are parallel lines. So the distance of Q from the y-axis is x2, and therefore the distance OS is also x2. Now what about OR? OR is about the x coordinate of point P. What is the x coordinate of point P? It is x1. So whatever is OR is parallel to this distance of P from the y-axis. So both are parallel lines. That's why the distance OR will be similar to the distance of the y-axis to this point P. That will both will be x1. So what is RS? RS is x2 minus x1, and this RS is parallel to PT. Therefore, the distance of PT is also x2 minus x1. Similarly, let us take that this distance from here to here is y2, and we will subtract the y1, which is over here. This is the y1 is the y coordinate of point P. So this much distance is y1. The distance of point P from x-axis, vertical distance. The vertical distance of point P from x-axis is y1. Horizontal distance is x coordinate and the vertical distance is y coordinate. So the y coordinate is y1, so it will be the vertical distance. Here the y coordinate is y2, hence it will be the vertical distance of point Q. Now subtract y2 minus y1. Then what shall we get? We will get the distance Q to T. Right? If you subtract y2 minus y1, this much distance is subtracted, then this much distance is remaining, and that is y2 minus y1. Now, once you have arrived at the lengths of PT and QT, you can apply Pythagoras theorem. What is the length PT? It is x2 minus x1, which is the horizontal distance of from P to T. And what is QT? It is the vertical distance y2 minus y1. Now we want to find the distance PQ. Apply Pythagoras theorem, which I'll show you in the next slide. Here I have shown you the distances OR is equal to x1, this distance, and OS is equal to x2 means this distance. RS is x2 minus x1, which I already told you. This is the horizontal distance from R to S, and RS is parallel to PT. Therefore, PT will also be x2 minus x1. Similarly, SQ is y2. SQ means this one. I showed you just now. This I have mentioned it over here. And ST. ST is equal to PR. This ST and PR both are equal. Now, in PR, the vertical distance is y1. Therefore, in ST also it will be y1 because both are parallel lines. So, ST and PR are parallel lines because they form parallelogram. So, this is y1. Therefore, QT from Q to T, as I mentioned you, it is written over here, it is y2 minus y1. Now here we are going to apply Pythagoras theorem. You can see it, x2, y2 here and x1, y1 here. These are the coordinates, and you are going to find the, here this is the distance, x2 minus x1, horizontal distance, y2 minus y1, vertical distance. Apply Pythagoras theorem and find D. The distance of, this is the distance of the hypotenuse. Now when applying Pythagoras theorem in triangle PQT, we get PQ squared is equal to PT squared plus TQ squared. Here this is the distance of PT, which is the horizontal distance, and TQ, this is the vertical distance. Now applying the Pythagoras theorem, you get x2 minus x1 whole squared plus y2 minus y2, y2 minus y1 whole squared. Y2 minus y1 whole squared is the vertical distance, that is TQ squared. But this is the value of PQ squared, but whereas we want the distance PQ only, not square. We want only distance PQ. In order to find the distance, we have to remove the square. How can we remove it? By getting the square root. So we take square roots on both the sides. Here it will become square root of PQ squared will be PQ. And what will be the square root over here? This is the formula which you get. This is the distance formula. Now here I would like to tell you one thing, that you can even interchange. You can take x1 minus x2, x1 minus x2 whole squared also. Similarly, you can even take y1 minus y2 whole squared. It will make no difference in the answer. Suppose if you think that x2 minus x1, here if you are getting 4, and x1 minus x2 is minus 4. But what will be the ultimate answer? Both will get the same answer, 16. Even after this minus 4 will become positive after getting squared. So that is why we can interchange this coordinates. You can write x1 minus x2. But be careful that here if you are writing x1 minus x2 and here if you are writing y2 minus y1, then you won't get proper answer. So be careful about that. If you are writing x1 minus x2, here also you will take y1 minus y2. Or if you take this way, then also it is proper. X2 minus x1 whole squared plus y2 minus y1 whole squared. And this formula is called distance formula. And this distance formula is used to measure the distance between any two objects, which are before this I gave you an example of watch and TV. So you can use this formula to find the distance between any two objects in space, any two objects on the universe, anywhere. Just take the two objects, take their vertical distance, take their horizontal distance, then the vertical distance, and here they are with the hypotenuse. Take any two objects. Now, suppose one object is here, one object is here. What should we do? Take one horizontal line, take 90 degree. This is the vertical line, take 90 degree. That's all, and apply the Pythagoras theorem. And use this distance formula, and the distance is ready. So it's not a big deal. Now here is a sum where you have to find the so that these are the coordinates of the isosceles triangle. Here I have taken a triangle, and on the three vertices S, C, Q, S, C and B, I have taken the coordinates, x coordinate and y coordinates of each point. This S is a point, the x coordinate and y coordinate is -1 and 4. Similarly of C, 0, 1, and of B, 2, 5. Now we are going to use distance formula in all the three to find the distance of the three sides, or you can say, or you can even say to find the distance SC, then CB and SB, or you can even say that to find the lengths of the three sides. Both mean the same thing. So here you are seeing, I will use the distance formula. I am getting √10. See, -1 -0. What is -1 -0? It is the subtraction of the x coordinate, this x coordinate, x1 minus x2, -1 -0. And similarly, you take it squared, square it, then plus y2 minus y1 squared. So let us take this as y2, 4 minus 1 whole squared. 4 minus 1 whole squared is 3 squared. -1 minus 0 has nothing to do. So -1 whole squared is 1. 1 plus 9 is √10. Similarly, you have to apply everywhere the same process. You see that in two cases we are getting √10, and in one case you are getting 2 √5. It means two sides are equal. Hence it is an isosceles triangle. Which are the two sides? SC and BS. You can say that distance SC and BS are equal, or the two sides are equal. Hence it is an isosceles triangle. Just in the way which we found the isosceles triangle, you are going to find whether this is a right angle triangle or not, or it is which type of triangle. Here it will be a right angle triangle. So you just find out how it is, you are getting the right angle triangle. And you can even apply the Pythagoras theorem and find out whether it's a right triangle or not.